Hey, Nate,
Yeah, Sam.
can you name all the planets in the solar system?
I can because I learned a fancy little saying in kindergarten. Do you remember what it is?
My very eager mother just served us 9 pizzas.
Right.
Wrong.
What?
My very eager mother just served us nothing because
What?
Pluto's not a planet.
I want my pizza back.
So I was raised with Pluto as a planet.
Right.
But if Pluto's not a planet, what is a planet?
I don't know.
Hey,
I got a question about that. Welcome to another episode of Hey, I Got a Question About That.
I'm Sam.
I'm Nate, and this is a podcast and video series where we talk about all the fascinating research going on here at the Eberly College of Science at Penn State.
And today on the podcast, we are joined by Chris Palma. He's the Associate Dean for undergraduate students in the college and also a teaching professor of astronomy and astrophysics. And Chris has opinions about planets.
And just about anything else that's in the solar system and space.
That's right.
Yeah.
It was a great talk. Let's get to it. So we're joined here in the studio by Chris Palma. He's the Associate Dean for undergraduate students and a teaching professor of astronomy and astrophysics here at Penn State. Thanks for joining us, Chris.
Sure, happy to do it.
Can you first tell us a little bit about what you do?
Yeah, sure. So, teaching professor, right, implies I teach, right? And that's where I've really been focusing my efforts at least 10, 15 years now. But I am a trained observational astronomer. And in fact, my research really concentrated on stars, stellar populations in the Milky Way galaxy. But these days, I've been much more interested in teaching a variety of different astronomy courses, and I've veered into education research, trying to study how people teach and learn astronomy best.
One of the things we want to talk to you about is, so when I was a kid, there were 9 planets. And I guess I kind of always assumed, if anything, that number would go up. But what's kind of the situation now?
Yeah, so you would not believe, as an astronomer, how often people are like, when I was a kid, there were 9 planets, right? My favorite response to that is, if you were growing up in the 1850s, it would be, when I was a kid, there were 12 planets, right? Because there were. And the other thing, right, is I don't know why. This comes up every year. It seems to come up over and over and over again. It was just in the news again because I guess the new administrator for NASA declared Pluto should be a planet again, and he doesn't care what anybody else thinks. But I'm here to declare Pluto is not a planet. Yeah, it can still go up, right? The number can still go up. There's a pretty significant effort going on, and there's some pretty good evidence to indicate there might be another planet, so it might go back up to 9. But if Pluto, we have to get over it. It's not a planet anymore.
So I guess what this gets into is how do you define what a planet is?
Yeah. So this is probably, at least to me, this is more fun than you might think. So I am teaching a class this semester that's called Fundamentals of Planetary Science and Astronomy, and I'm very upfront with the students. And I think this is sort of a key piece of this particular discussion, right? There is a difference between astronomer and planetary scientist, and there's a difference between astronomy and planetary science. Penn State has a Department of Astronomy and Astrophysics. We do not have planetary science really well established here. You can major in it. There's a major planetary science and astronomy. There are a handful of faculty that's their expertise, but I don't think anybody at this university would be upset with me in saying that, Penn State doesn't do planetary science. But of course, then if you ask people, well, what is astronomy? Don't astronomers study the planets? There's this subgroup of people that study the planets, but the people at Penn State study things like stars and planets around other stars. They study the Milky Way galaxy, nearby galaxies, distant galaxies, exploding stars, black holes, quasars, cosmology, and really none of that is planets, right? The two fields diverged years ago and are now starting to converge again in the sense of, as we're finding more and more planets around other stars, it is causing planetary scientists and astronomers to get back together to compare notes on these planets around other stars. But coming all the way back to, what is a planet anyway? I love going back to the origins, right? And what does planet mean? Because it's a fundamental question in astronomy. So you go outside, you look up in the sky, and this is a great time to do it, right? Go outside, look south, and the brightest thing you see in the southern sky is Jupiter, right? If you watched really, really carefully for, say, a month, you would notice that Jupiter moves differently on the sky than the stars do. So night after night after night, the stars come back to the exact same position. That's why we call the stars that make up Orion, Orion, because for human history, those stars in the Orion's belt are always in the same part. On the other hand, if you picture Orion up in the sky and you picture, well, okay, here's Jupiter up here, and you tracked it with respect to Orion, a month later, Jupiter has moved with respect to the stars. So, and any fans of the TV show The Big Bang Theory?
Sure.
Right, okay. So they turned this into a joke on The Big Bang Theory. There's an episode where Sheldon is trying to teach Penny about astronomy, and he's like, let's start in a warm day in ancient Greece. And so the origin of the word planet comes from the Greeks, and it means wandering star. So there's a set of objects on the sky that we call stars that behave one way, and there's a set of objects on the sky that behaved a different way. And so the word planet was used to describe them because they move differently than the stars. So here's when people really get riled up about what's a planet anyway. Well, I say, well, what is a planet anyway? The original definition, if you go by the word planet, the definition of planet is Mercury, Venus, Mars, Jupiter, Saturn, Sun, Moon. That's what the word planet came from, right? So we don't call the sun a planet anymore, right? So that's changed. We don't call the moon a planet anymore. Did you notice something missing? What's missing from the list of planets?
Our own
Earth.
Yes, right? So the original definition of planet was based on how objects moved on the sky. Earth doesn't move on the sky. So Earth was Earth. And the planets were the moving objects on the sky. So the original definition was Sun, Moon, Mercury, Venus, Mars, Jupiter, Saturn. So since then...
Are those kind of the things that you can see with the naked eye? Is that...
Yes, right? So Uranus wasn't discovered till many hundreds, right? Almost 2,000 years later. Neptune after that. So Uranus and Neptune were not discovered when the word planet began to be used commonly, and so they weren't considered planets. And when they were discovered, it's like, oh, well, they're planets. So that's what's happened, right? Science has moved on. We've discovered new things. We use the word differently than it was intended. So when people give me a hard time, like Pluto was a planet when I was a kid, well, if you go back to 2,000 years ago, the sun was a planet when some people were a kid, right? So that's kind of why I honestly feel and this is what I tell my students when we work on this class, the word planet, the way we're using it today, it's basically obsolete. We really should say planet was originally coined to describe that set of objects. And the things we call planets today and what we think we mean when we use that word is not the way we're using it today. So when people say, oh, there is a formal definition that means this, that's trying to retrofit a definition so that when you say the word planet, people think they know what that means. And so people are trying to come up with a definition so that anything you think of as a planet is one. And there's no way to make that work. So it really applies to all the objects you think it should apply to. So how is that for a really long answer to a really short question?
That was great.
So like what part is Pluto missing? Like why is it not considered a planet now?
Yeah. Okay. So, and there's absolutely two different ways to answer that question. And so I'll give you the way I prefer, and then I'll give you the contrary view. So here's what I do with my students, and this is why we've done presentations on this. I've done it in classes, and here's the way I think I know I can do this well. Is my wife will tell people, she's like, oh, he convinced me Pluto's not a planet, so he can convince anybody, right? So what I do with my students, I tell them, okay, I'm gonna break you up into groups. I'm gonna give you properties. You're gonna look at the density of objects in the solar system. You're gonna look at the masses and sizes. You're gonna look at whether or not they have moons. You're gonna look at whether or not they have atmospheres. You're gonna look at how far they are from the sun. And I ask the students, okay, I want you to look at those properties, and I want you to start from scratch. I want you to come up with a classification scheme that groups the objects based on those properties. So, and if you do that, you pretty quickly, the students gather like, oh, he's just trying to make me rediscover the difference between the inner planets and the outer planets, right? Like, so the inner planets, Mercury, Venus, Earth, Mars, they share roughly sizes, densities. They have very few moons. The outer planets, Jupiter, Saturn, Uranus, Neptune, they share things like sizes, densities, compositions, numbers of moons, presence of rings. Pluto doesn't share those properties with any of those objects, right? Its orbit is different. Its rotation is different. Its density is different. So there's a lot of properties. Like if you try to do that exercise, like let's look at the set of measurables for objects in the solar system, and you say, okay, here's the range of measurables that I would describe any object with this set of measurables as a planet. Pluto shares almost none of them. It's got a density it's less dense than planets like Earth and Mars, but it's more dense than planets like Jupiter and Saturn. Location in the solar system, it's further away. One of the real defining characteristics of the 8 objects we call planets, they orbit the sun in basically a flat plane, right? There's a little bit of variation, and Pluto's orbit is tilted by about 20 degrees. So the plane of its orbit is different. And then the one that was sort of retrofitted into this definition, the 8 major things we call planets, for the most part, they are the dominant object where they are. So what that means is if there's some little object that passes within the range of influence of Jupiter, for example, Jupiter will either fling it out of the solar system, fling it in towards the sun, capture it. Jupiter is the dominant massive gravitational body in our solar system besides the sun. Pluto is just one of a whole set of objects, and it's part of the solar system, and there really isn't a dominant object out there. And so Pluto has no gravitational influence over that part of the solar system. And so it's one of a very, very large group of objects in a particular area of the solar system. And those objects have names. We variously refer to them as trans-Neptunian objects, just means an object out past Neptune, or that area has become known as the Kuiper Belt or the Edgeworth Kuiper Belt. And so there's like if you today discover a new object out where Pluto is, we would just say, oh, that's a Kuiper Belt object. And so when Pluto was discovered all those decades ago, it was the very first of those found. And so the assumption was, oh, here's this new planet. It's the only object out there. Since that time, we've discovered tens of thousands of objects out there that share properties with Pluto. So Pluto has properties more like the set of objects we call Kuiper Belt objects. So that's where I go. Kuiper Belt objects, Pluto's like them. We can circle back to why that's not a planet. So what's the contrary view, right? Most of the objects that you would find in the Kuiper Belt are irregularly shaped. Like if you have a picture in your head of the Millennium Falcon flying through the asteroid belt in it was Empire Strikes Back, right? I think so.
Yes.
It's going to hurt my breath.
Okay.
Yes.
Yeah. I know. Is that me too? So if you picture like a traditional asteroid belt, like as a lumpy rock with craters in it, right? So the asteroids in the asteroid belt are primarily lumpy, misshapen things. The objects in the Kuiper Belt are primarily lumpy, misshapen things. Pluto's round, right? So that is an interesting, again, if you sort of look at the properties and say, what objects should we call planets? What objects should we call something else? There is a fundamental difference between some objects are nearly spherical and others are not. So the people who argue that Pluto should be a planet, that's one of the things they want to see in the definition, that, hey, it's different. It's more like a planet because it's round. So you might say, I buy that, right? Okay, so if you buy that, so then the argument is that anything that's round belongs in this category. There's something like 100 or so objects that are massive enough and have properties that would make them round. So if you buy into the Pluto's a planet, then it's not 8 planets or 9 planets, it's 100 planets, right? And so that's sort of the two views today. Like if we exclude Pluto, then we're excluding all these other round objects, and that's what I would vote for. If we create a definition that includes Pluto as a planet, well, then Ceres is a planet, and Makemake is a planet, and Eris is a planet, and Sedna is a planet, and the list just goes on and on and on.
Is Pluto the 9th biggest thing in Earth?
So that's another fun one, and this is one of the things I, again, sort of from a teaching perspective, I say let's rank the large things in the solar system, right? So start with Jupiter, then Saturn, and you go down and down and down. So in fact, Mercury is not like if you think of the 8 planets as they're the 8 largest, Mercury is not the 8th largest object in the solar system. There are 2 moons, Titan, moon of Saturn. And now since I'm going from memory, Ganymede. So of the 4 large moons of Jupiter, Ganymede is the largest, and Ganymede and Titan, which we call moons, we should come back to what is a moon anyway. Titan and Ganymede are larger than Mercury. So there's 6 or 7 moons that are larger than Pluto.
Pluto's smaller than our moon, right?
Yeah. So, and that's the thing, right? So put yourself in the shoes of wanting to argue that Pluto should be a planet, right? So oftentimes, well, let's look at the big things. Let's look at and there's really nothing that makes Pluto special in some way that would put it, I mean, the 8 objects that we do call planets, they really are special in the sense of like you can define a set of properties that really separates them from the other objects. There's nothing that makes like you in order to expand the definition to include Pluto, it includes so many other, like the moon. Our moon would have to be called a planet if you wanted Pluto to be called a planet. And there are some people who say, well, let's go with that. And right, but most of the time, people who argue that Pluto's a planet they want that's one special thing to be a planet.
Sure, because nostalgia is a good reason to call something a planet, right?
Yeah, exactly.
So. What is a moon then?
What is a moon? Yeah. So that's and this is one of those things too that I as I've gone further down this rabbit hole, I've thought more about this a little bit and read a little bit more. So can I do the classic teacher thing and reverse the question on you? What is the name of the moon?
The moon.
The moon.
The moon, right? So every once in a while someone will say Luna, right? So then you might ask, well, okay, do astronomers or scientists in general call the moon Luna? No, we call it the moon. So the idea of what is a moon, right? And again, you would say, oh, well, the moon is some object that's not primarily orbiting the sun. It's primarily orbiting another object, right? So the moon orbits the Earth, and the Earth and moon system orbit the sun together. Well, that's not how the moon was defined, right? So again, go back to pre-telescope era when people were naming things. Look, there's this bright thing up in the sky. Moon, right? No other moon was known for hundreds of years, right? So the telescope was invented and Galileo discovered these objects orbiting Jupiter, and now the word moon is being applied in a different way, right? So moon now refers to, well, Jupiter has moons like the Earth has moon, and we named them Io, Europa, Ganymede, Callisto, and we started calling them moons of Jupiter. But now the definition of moon is different, right? And so this is where when you try to retrofit definitions, it gets so hard because so if you say a planet is this object that orbits the sun, and a moon is an object that orbits a planet. So then you have to define what you mean by orbits a planet, right? Because you have to decide whether something fits that definition. So when you talk about orbits, you talk about what's the center of mass of the orbit, right? So the Earth orbits the sun, and there's a center of mass between the sun-Earth system. The moon orbits the Earth, so there's a center of mass. So I've heard people start to say, like, okay, a moon is a moon if the center of mass of the planet-moon system is inside the planet. Does that seem reasonable? Right. Okay. So so you could say, okay, well then that makes the moon and the center of mass of Io, for example, is inside Jupiter. So then Io makes sense as a moon. The moon, just because of physics, is moving away from the Earth as time goes on. And there's a number of different, we can directly measure this. The Apollo astronauts left behind these little mirrors on the moon, and we can shine a laser from Earth, hit that mirror, and measure the time it takes for the beam to come back. And you can measure the distance between the Earth and the moon to centimeter accuracy. It's really impressive. So we can actually see that the moon is getting about a centimeter further away from the Earth every year. So what that means is that sometime in the future, the center of mass of the Earth-Moon system will be outside of the Earth. So that means today we would call the moon a moon, but at some time in the future, the moon is no longer a moon. So that's why, so again, there's this definition floating out there for planet. And so the way that definition works, Earth is a planet, and we would all agree Earth is a planet. So the people who disagree with that definition argue, well, what if we could magically put the Earth out where Pluto is? Earth is not gravitationally significant enough to clear the Kuiper belt. So Earth is a planet here, but if we moved it out past Neptune, it wouldn't be a planet, right? And so that's a problem with this retrofitted definition, is that the things you call planets are only planets given the way they are now, and as time goes on or things change, they wouldn't be planets anymore.
And I guess
You're blowing my mind here.
Exactly. I mean, I guess the other question, I mean, there's thousands of objects that are orbiting the Earth, right?
Yeah.
They're not all moons.
Yeah. So well, okay. I guess, yeah. So you mean like artificial satellites?
Yeah.
Okay.
Well, and isn't there other natural objects out there too?
So, well, I guess that's where you have to be a little careful. So orbiting the Earth, right? There are other there is another object that sometimes gets referred to as Earth's second moon. So it's an object that if you track it's orbit, it's on a really interesting orbit, but it is being gravitationally influenced by the gravity of the Earth. So that's one way to think of it, as a moon. But there's no other significantly massive object that really behaves the way the moon does, right? That where it follows the Earth around its orbit in an elliptical orbit. But artificial satellites, right? The Hubble Space Telescope, the International Space Station, they're technically moons, right? And again, to go back to Star Wars, that's no moon, right? So the Death Star. So those things are moons, but they are gravitationally bound to Earth, and Earth is what's keeping them in their orbit. Coming back to your question, though, there are objects that are found along Earth's orbit, right? So they orbit the sun at roughly a distance that's consistent with ours, so they can cross our orbit. So the Earth's orbit is not completely devoid of other objects, but those objects primarily orbit the sun rather than primarily orbiting the Earth. So it's a little bit of, more semantics, which is what this whole thing's about.
Right.
Yeah.
Yeah. I mean, so I guess part of it is, our kind of need as humans to classify things.
Yeah.
And the definitions that we have are useful, but is there a broader way of thinking about objects in space?
Yeah. So that's why, and this is where I'm coming from. And this is why this is one of those things that separates astronomers. You're in the Pluto is a planet camp or you're not. And it's one of those things that people have entrenched opinions and they want to fight about it for some reason. And I will say, like a lot of entrenched opinions where I don't totally get the other side of the argument. I do get that Pluto's round and it has objects that orbit it. So it has moons, using the modern definition of moon rather than the original definition. So there are things that make it look like a planet. But here's the thing, right? So if you say, where did the 8 classical objects we call planets, where did they come from? We think the process of planet formation is a bottom-up process. You have a lot of small objects that collide, stick together, and over time, those amalgamations of stuff turned into distinct objects that we would call planets. So there are asteroids in the asteroid belt. There are asteroids throughout the solar system. There are objects that we call Kuiper belt objects out where Pluto are. We think many of those objects are building blocks of planets. So at least in my head, the way I think of the objects we traditionally call asteroids, and that's another fun, where did that word come from and what does that mean? But if you think of these sort of lumpy, misshapen objects out in the asteroid belt, they formed from the bottom up, but they didn't form all the way to a planet. There weren't enough of them, and the process of planet formation didn't happen in that part of the solar system. So you didn't get a planet there, and there's left behind objects that were building blocks for planets. So the Kuiper belt is the same thing. Those objects in the Kuiper belt are objects that were part of the planet formation process that didn't end up in a planet. So Pluto, to me, got some of the way down the pathway towards becoming a planet, but didn't, right? So it's its own kind of object that's kind of part way between one of those small building blocks and a true planet. And at least in my head, that's what I think of it. And Kuiper belt object doesn't fully capture that, because there are very small, they're probably like teeny tiny Kuiper belt objects, and Pluto is a substantial one. But at least to me, it's a building block object. It's an object that was on the pathway towards planethood and just didn't make it.
So what about asteroids?
Okay. Yeah.
What's the deal with asteroids?
What's the deal with asteroids? Yeah. So, and this is one, there's some fun articles out there about this, right? Because you can look up where did the word asteroid come from, and it's attributed to an astronomer named Herschel. And Herschel made a bunch of significant discoveries, so his name comes up. But apparently some historian of science spent an awful lot of time and tracked down that, yes, Herschel was involved in the discovery of those objects, but didn't have a word to call them. And so there was a historian who focused on Greek, and he threw out a bunch of different like Greek style words that could mean what this object was. And so if you ask most people, they say, oh, Herschel is the one who invented asteroid, but it was actually this other person. Okay, so what is an asteroid? And this comes back to the thing I said early on, like in the 1800s, there were 12 planets. So there's a really interesting thing we think is a coincidence in the solar system. And that is that as you go from Mercury out to Neptune, the distance is roughly double, right? So Venus is roughly twice as far from the sun as Mercury. And then you have to skip Earth. Mars is about twice as far as Venus. When you get to Jupiter, Saturn is twice as far as Jupiter. Uranus is twice as far as Saturn, right? So I skipped, right? I went from Mars. Twice as far from Mars as Jupiter is the asteroid belt. So there was no, so when people notice this coincidence of you double the distance and there's a planet, it predicted, if you will, that there should be a planet at roughly 3 times the distance from the sun that Earth is. And so people were intensely looking in that area because they thought, oh, there should be a planet. And that's when people started to discover objects there. They discovered Ceres and Vesta and Pallas and Juno. And so there was a time when if you were a kid and you were learning the names of the planets, it was Mercury, Venus, Earth, Mars, Ceres, Vesta, Juno, Pallas, Jupiter, Saturn, Uranus, Neptune. So the largest asteroids were considered planets for a time. But the largest asteroids are very small. So Ceres is small, Vesta small, Juno small, Pallas is small. So asteroid means star-like. So these astronomers were finding objects that they said, oh, we've discovered a planet. But even with the sort of crude telescopes at the time, you could make out that Uranus was a disk. Like if you buy a nice $500 telescope and you point it at Uranus, you can tell it's not a star. It's got a disk to it. You can't do that for the asteroids. The asteroids, they move like planets, but they look like stars. So that's what that name means. Moves like a planet, looks like a star, star-like. And it took really powerful telescopes to resolve them and tell that they were in fact disks, but they're much smaller. So off the top of my head, I think Ceres is hundreds of miles across, right? So significantly smaller than Earth's moon. So you have the set of objects that were they planets? No, they're just small objects. And then when Pluto was discovered, it was similar, like, oh, we've discovered a planet, but Pluto, in a lot of its properties, is more like an asteroid. It's small, so it's unresolved. And one person that I who's done a lot of work in this area, who we've actually invited him to Penn State, and he's given a talk about this. And here's a good place to put in a plug. Some of these public presentations we do on astronomy, we record them. And so there's a great one. This person's name is Mike Brown. He's a professor at Caltech, and he's discovered some of the objects out past Neptune. And his Twitter handle is Pluto Killer. And the book he wrote is How I Killed Pluto and Why It Had It Coming. And he's the one that discovered a lot of these objects that triggered this whole discussion. So he gives a talk on this, and he looked up some of the stuff that was being published around the time that Pluto was discovered. And originally, when it was first discovered, it was assumed it's in the part where the giant planets are. It's got to be a giant planet. So when it was discovered, when they made more measurements and they noticed Pluto was small, suddenly there were all these really off-the-wall ideas for, well, how could this object that's presumably a giant planet be so small? And one of the ideas was it was uranium, right? It was an ultra-dense thing. That's the only, like, that it had to be ultra-dense, right? So, so we find these objects in between Mars and Jupiter primarily, and out beyond Neptune, and they have very similar properties of being very small, so they look like stars. And so honestly, the word asteroid kind of perfectly summarizes what I've been calling Kuiper Belt objects, right? Because the Kuiper Belt objects do share a lot of the same properties as asteroids. The big difference is composition. Asteroids tend to be almost exclusively rocky, whereas Kuiper Belt objects tend to be a mix of rock and ice. But other than that, there's a lot of overlap. So asteroid is honestly a perfectly good word to, and it's, and the way it was coined, moves like a planet. So, but appears like a star because it's so small, that still applies to all of those objects. So I like that word a lot. It's a pretty good, like the way we're using it today matches pretty well with what it really is. But I sort of leave this whole discussion with my students with, you probably came into this class saying, I know what a planet is. You're not going to convince me other word. I know what a asteroid is. I know what a moon is. But when you get into the details, right, we're not using those words today the way they were coined. And so if we retrofit definitions onto them, the objects you want to classify in that way don't work. So, and then throw on top of that, which I know you've talked about with other people, exoplanets, right? So you have these planets around other stars, which have been called extrasolar planets, exosolar planets, and now most people today call them exoplanets. So that's another layer on top of this. And we had a room full of very accomplished scientists talking about this idea of teaching more planetary science at Penn State and doing more research because we have so many exoplanet scientists. And even they said, they're like, the word planet doesn't really work because it doesn't, especially now that we have thousands of new objects we're calling planets. So this is something we're trying to work out. Like, what if you today were in charge of creating a center at Penn State studying objects in the solar system and objects around other stars that for the most part we call planets, but now knowing that the definition of planet doesn't really work, what would you call that institute, right? Right. And that's my argument. We need to coin a word today that does encapsulate what we mean and can maybe finally once and for all stop making Pluto come up every year as like, is it a planet or not? And yeah.
So do you have your suggestion to?
So I am not the kind of person that you want naming things. I'm not creative in that way. I just use world. I say, because world works for me. And it also, and what I try to do when I teach my students is like, you've probably learned Mercury, Venus, Earth, Mars, and all those things are fascinating. But because of the way in which we classify things as this is a planet, this is a moon, this is an asteroid. I mean, have you ever thought too much about Ceres? No. Ceres is a fascinating object, but it's an asteroid, so it kind of gets ignored. Another one that's super fascinating is Titan. Titan is probably one of the most interesting objects in the whole solar system, but it's a moon of Saturn. So as a moon, it doesn't quite get thought about in the same way. If Titan were orbiting the sun and it would be called a planet. It's larger than Mercury. It's larger than Pluto. And I try to argue to my students, like, we should be studying Ceres more. We should be studying Titan more. We should be studying Europa more. And part of what we call them, they don't have that same sort of level of across the board interest. So scientists care about them, but I don't know, like the people who argue about the name of whether we call Pluto or planet probably don't care as much about Titan, but I would argue in a lot of ways Titan's more interesting than Pluto, right? So I just use world. And I say Titan's a world, Ceres is a world, Pluto's a world, exoplanets are worlds, but world has its own connotations that are, yeah. Can I throw in one more fun thing?
Sure.
Okay. So I'm sorry if I'm talking too much and not giving you enough space to talk. As you can tell, I teach a lot and I care about these things, so it's fun. So here's one of the ways I sort of leave my students is I don't necessarily care what you call the objects, but I want you to understand sort of the range of properties that are out there. So you have these objects that are, we would call them rocky or terrestrial worlds. And so they roughly have sizes around the size of Venus and Earth. They have densities of a certain number. They are in the same rough part of the solar system. If you look at slightly less dense objects, those are asteroids or Kuiper Belt objects, right? So I tell my students, like, if I give you a set of numbers, you should be able to predict where I would find that object in the solar system, what it's made of, whether or not it has an atmosphere, whether or not it's likely to have moons. And so you do all that, and then okay, what are the really weird things? So the densities of objects in the solar system, you have objects that are mostly gaseous, and they have one density. If they're kind of a mix of rock and ice, they have a density that's about twice that much. If they're mostly rock, they have a density maybe 3 times as high, right? So, and that's pretty much it. You have gaseous objects, mixes of rock and ice, and then rocky objects. So one of the upcoming missions that NASA has planned is to go visit an object called Psyche. Anybody heard of Psyche? Right? So the density of Psyche is something between 2 and 3 times more dense than Earth. So what do you think Psyche's made of? Denser than Earth.
No clue.
So here's your quiz for the podcast. What's Earth mostly made of? Like when you think of Earth. Just generically, when you pick up stuff outside, what do you pick up off the ground?
Rock.
Mineral. Right. Okay. So rock. So
I
Earth
was going to get specific. And
Yeah.
Like the actual.
Earth is we would just as generic and as Earth is a rocky world, right? And so the density of the material that Earth is made of, it's less dense where we are on the crust, and it gets denser as you go down to the center. So this object called Psyche is essentially 100% metal. So there's this object that's orbiting the sun that's, from what we can tell from the measurements we're making here on Earth, it's pure metal, right? So, and that's one of the reasons why they want to go check it out. Why would you have an object of pure metal rather than an object that's a mix of metal and rock and ice and everything? One of my students did a presentation on it and actually calculated. So there has been this discussion about, should we mine these objects, right? You can go get, material that's not as common on Earth. So one of my students calculated like the amount of rare metals on this thing is probably worth $1 quadrillion. So if you could get there and you could mine it and bring it back to Earth, you could be a quadrillionaire, right?
So what you're saying is it won't be long until
People are thinking about it.
SpaceX is heading in that direction.
Yeah. So
Well, this has been fantastic
Okay.
and fascinating. Thanks so much for joining us.
sure,
Chris.
it's you let me pontificate about my favorite things. So why would I turn you down?
Thanks.
Great.
Sure.
Wow, Chris knows a lot about space.
Yeah. And I guess nostalgia isn't sound scientific reasoning.
No, but I think it's a good point to make that, just because we think we know something doesn't mean we should stop learning about it or researching it because, things change.
Right. And that's the beauty of science, is that it's a constantly evolving body of knowledge.
Exactly. So if you want to learn more about Chris or any of the research going on here at the Penn State Eberly College of Science, we will have links in the show notes below.
Thanks for joining us on another episode of Hey, I Got a Question About That. And if you haven't already, check out our previous episodes. You can find us wherever you get podcasts and on YouTube.
And please be sure to like, subscribe, and leave us a comment.
Hey, Nate.
Oh,
That was the one. First take, magic. Gold.
don't.
Maybe we won't get enough outtakes.
We'll just sit here and swear. Can I go on record to say, again, Hank owes us $1.5 million for a new studio. I have the footage, Hank. I'm coming for it.
Let's go straight through.
All right. Someone's big for their pants today.
Hey, Nate.
Yes, Hank.
Did you ever grow a old-timey mustache?
Why, yes, I have. We're here to talk about planets, say. You expect less from us? We are stars. So if you want to learn more about Chris's Nope. I had to get a nope in.
Thanks for joining us. Make sure you check out any of our...
We're doing good there.